Hello, welcome back to 11.4, which is matrix algebra. So we're going to be doing stuff with our matrices once we have them. So first we're going to start with adding and subtracting matrices. So first of all, in order to add or subtract matrices, the two matrices, or more, actually you can do more, must have the same dimensions. So you can add a 2 by 2 with a 2 by 2. You could add a 2 by 3 with a 2 by 3, but they must match. Must have same dimensions. And then you're going to add or subtract the corresponding parts. So like row 1, column 1, you would add with row 1, column 1 from the other matrix. Okay, so for example, let's say we have matrix A. And it equals 0, 1, 3, 2, negative 5, 6. And then we have matrix B, which is 4, negative 2, 1, 3, and 0, negative 2. And for number 9, we're going to add those two matrices together. So number 9, we're going to do A plus B. And like I said, you just add the corresponding parts together. So we have 0, and we'll add it to 4 and get 4. 3 plus 1 will be 4. Negative 5 plus 0 will be negative 5. That's the first row in each one. Then the second row, 1 plus negative 2 is negative 1. 2 plus 3 is 5. 6 plus negative 2 is 4. And that's your resulting matrix. That's your answer. And then number 10, we're going to subtract the two matrices. We're going to do A minus B. So 0 minus 4 would be negative 4. Three minus 1 would be 2. Negative 5 minus 0 would be negative 5. 1 minus negative 2 would be 3. 2 minus 3 is negative 1. 6 minus negative 2 would become 6 plus 2, which is 8. And so that's your resulting matrix for A minus B. And then the commutative property applies to matrices just like it did in algebra, like 2 plus 3 is equal to 3 plus 2, those kinds of rules. That one applies here too. Not all of them will. So commutative property of matrix addition is that you can do it both ways. Okay, so if you were to add A plus B, you would get the same result as if you did B plus A. So that's what commutative property of addition means. And then the associative property of addition also applies, where you can move the parentheses and they're still equal. Okay, so if you have A plus B in parentheses, and these are capital letters, so they're matrices, A plus B, and then you're adding C on the outside, it's okay if you move the grouping symbols. So like A could be alone, and then you add B plus C in the parentheses. Okay. Then before we get to the next one, we'll talk about the zero matrix. Zero matrix is pretty much exactly what it says. It's a matrix of all zeros. Okay, so generally a square matrix, but this is a 2 by 2 zero matrix. All right, before we get into actual multiplication of matrices, which actually is a little bit tricky, we're going to talk about scalar multiplication first. This is just multiplying an entire matrix by a number. Alright, so this is just multiplying an entire matrix by a non-zero number. I guess it could be 0 too, though. So multiplying a matrix by a number. Called the scalar. It's pretty much like the distributive property with algebra. Or for algebra. Okay, so for example, on number 12, we have that matrix B from before. Same one. I'm not changing it. I'm just writing it down again. So we had matrix B. It was 4, -2, 1, 3, and 0, -2. Okay, so that's our matrix B. And number 12 says define -3B. So -3B would just be -3 times the entire matrix of B, and you just multiply it times everything. So 4 times -3 is -12. -3 times 1, that's -3. -3 times 0 is 0. -3 and -2 is a +6. -3 and 3 is -9. -3 and -2 is 6. And that's your answer. Like I said, scalar multiplication is pretty nice. You're just distributing. All right, so the properties of our scalar multiplication. All right, if we have a scalar k, and then we're going to multiply it times h times the matrix A, you could just multiply your two scalars together. So k times h, and then times your matrix A. So h and k are scalars, and A is a matrix. Okay, so another thing that works is if you're adding two scalars together, so like k plus h, and you're multiplying it times the matrix A, you can distribute that. You can distribute your matrix A. So it'd be k times A plus h times A. And then finally, if you have a scalar times two matrices being added together, that's k times A plus k times B. You can distribute it. Okay, so back to that same example, but number 14. Still using A is 0, 1, 3, 2, -5, 6. And matrix B is 4, -2, 1, 3, and 0, -2. Alright, so if we were then asked, well, we are, on number 14, we're asked to find 2 times matrix A plus 4 times matrix B. I would go ahead and start by doing the scalar multiplication. So you can do 2 times the A. That'll give us, change colors. Let's see, 2 times 0 is 0. 2 times 3 is 6. 2 times -5 is -10. 2 times 1 is 2. 2 times 2 is 4. 2 times 6 is 12. Plus, and then 4 times our matrix B. 4 times 4 is 16. 4 times 1 is 4. 4 times 0 is 0. 4 times -2 is -8. 4 times 3 is 12. And 4 times -2 is -8. And now you can just add those two matrices together. They're both 2 by 3, so we're good to go. 0 plus 16 is 16. 6 plus 4 is 10. -10 plus 0 is -10. 2 plus -8 is -6. 4 plus 12 is 16. 12 plus -8 is 4. And then that's your final answer. So that's definitely some matrix algebra happening right there. Okay, so now we get to get into the matrix multiplication. I think this is fun personally, but I like math. All right, and this is a little more complicated than just saying the two matrices have to have the same dimensions. So it's a little more than that. Okay, so this is a matrix times a matrix, not just times a scalar. All right, so if you have matrix A, it is an M by R matrix, and you have matrix B, and it is an R by N matrix. The only way you can multiply two matrices together is if the middle two numbers match. So like for instance on these two, they're both R's. So we're going to multiply a matrix A and matrix B. The answer will be an M by N matrix. It's the ones that are left over if you took the R's out. All right. All right, so for example, if you just have, let's just start simple, a row matrix times a column matrix. I'll show you what I mean by that here in a second. Okay, our row matrix is something that's just a row. So we'll just call it A, B, and C. Okay, it is a 1 by 3 matrix. Our column matrix will be X, Y, Z. Okay, it's only a column. All right, so R is a 1 by 3 matrix. C is a 3 by 1 matrix. So the 3's match. That means the answer will be a 1 by 1. Okay, so let's do it with numbers. All right, we'll say R. Whoa, that's weird. I don't know if I've ever had that happen before. Let's say R is the matrix 3, 2, 1. And C is the matrix 4, 2, negative 1. And we are going to do R times C. Okay, so how it's a 1 by 1, so we're going to have one answer. You do like the first times the first, the middle times the middle, the last times the last, and you add them together. So we would do 3 times 4, which is 12, plus 2 times 2, which is 4, plus 1 times negative 1, which is negative 1. So R times C is the matrix. Let's see, that 16 minus 1 would be 15. Would be the matrix with just a 15 in it. Multiplication is definitely a little different. Multiplying two matrices, that is. All right, so let's do some examples with 3 given matrices. Okay, so from our examples, we have matrix A, which we have 0, 1, 3, 2, and negative 5, 6. We have matrix B, which is 4, negative 2, 1, 3, and 0, negative 2. And then we have matrix C, run out of space, which is 4, 6, negative 2, and 1, 2, 3. Okay, so this first matrix is a 2 by 3 matrix. B is also a 2 by 3 matrix. And C is a 3 by 2 matrix. All right, so number 18 says to multiply B times A. So the first thing I would do is figure out what your resulting answer would be. Like what the dimensions of your resulting answer is. Sorry. So B is a 2 by 3. And then A is a 2 by 3. Looking at the middle numbers, it's a 3 and a 2. The two middle numbers do not match. So you cannot multiply B times A. So the answer is not defined. Can't do it. If you try to do it in your calculator, which you can do, you can enter the two matrices and then just tell them to multiply. You would get error, I believe. All right, number 16, we're going to do B times C. All right, so let's see what we have here. B is a 2 times 3, a 2 by 3, I mean. And C is a 3 by 2. That's better because now we have the 3's in the middle. So that means our answer will be a 2 by 2. All right, so let me put the two matrices side by side. Okay, so B we have 4, negative 2, 1, 3, 0, negative 2. And we're going to multiply this times C, which is 4, 6, negative 2, 1, 2, and 3. All right. And our resulting answer will be a 2 by 2 matrix. Just get myself ready for that. Okay, so you're going to do rows times columns. And you're going to add everything together. So, let's get a pen out here. Take that bottom row away. On there. So we have the top. That means I'm going to do these top two first. And I'm going to take this column away for now. So I'm going to do that first row with this first column. This row with this column. That means it's going to be that first number up here. So 4 times 4 is 16. Plus 1 times 6 is 6. Plus 0 times anything is 0. Then I'm going to move this over to get the other top one. Move it over and move it up. Okay, so I need the top row of that first one, second column of this one, like is going to give me the top. 4 times 1 is 4, plus 1 times 2 is 2, plus 0 times anything is 0. Now I'm going to move to the bottom row, first column. That'll be this number down here. Negative 2 times 4 is negative 8. 3 times 6 is 18. Negative 2 and negative 2 is a positive 4. Switch to the other column. Negative 2 times 1 is negative 2. 3 times 2 is 6. Negative 2 times 3 is negative 6. So the answer, 16 plus 6 is 22. 4 plus 2 is 6. This would be 10 plus 4 would be 14. And the 6's would cancel out actually, so you have a negative 2. And that's your answer. Like I said, you can plug them into your calculator. I'm not going to do that right now. You can just find matrix B and matrix C and then multiply them. Or do it this way. Just kind of neat that it works. Alright, let's do one that's going to have a little bit bigger of a bigger answer. Let's look at number 20. Hopefully I'm not underestimating my amount of paper left. Okay, number 20, we're going to do C times B. We're going to go the opposite way. So C times B, you'd have a 3 by 2 times B, which is a 2 by 3. So this works because you have two 2's in the middle. Our answer will be a 3 by 3. I'm going to start the same way. I'm going to write them side by side. Alright, so C, we have 4, 6, and negative 2. 1, 2, 3. Then for B, we have 4, negative 2. 1, 3. And 0, negative 2. Alright, so our answer is going to be a 3 by 3. Alright, so I'm going to do that first row with the first column. As long as my pen doesn't roll away. To quit flipping over. Okay. So first row with the first column. 4 times 4 is 16. 1 times negative 2 is negative 2. Alright. Middle. 4 times 1 is 4. 1 times 3 is 3. Yeah. End. 4 times 0 is 0. 1 times negative 2 is negative 2. Right? That's it for the first row. Now we'll go to the middle row that has a 6 and a 2. 6 times 4 is 24. 2 times negative 2 is minus 4, or negative 4. With the middle, 6 times 1 is 6. 2 times 3 is 6. On the end, 6 times 0 is 0. 2 times negative 2 is negative 4. Then finally move into the last column. 4 times negative 2 is negative 8. 3 times 2 is negative 6. Negative 2 times 1 is negative 2. 3 times 3 is 9. Negative 2 and 0 is 0. 3 and negative 2 is negative 6. Alright, so then our answer. 16 minus 2 is 14. 4 plus 3 is 7. 0 minus 2 is negative 2. 24 minus 4 is 20. 6 plus 6 is 12. 0 minus 4 is negative 4. Negative 8 minus 6 is negative 14. Negative 2 plus 9 is 7. 0 minus 6 is negative 6. And that's your answer. Whew. I like those. I think they're fun. I like matrices. I wish they were taught more. I wish, like, for some of you, this is probably your first time being exposed to them. And I feel like they should have been introduced earlier in math. But that's my opinion. Okay. So there is no commutative property, which we actually did see on number 18 and 16, because when we reversed them, it didn't work. So there's no commutative property. There is an associative property. It actually doesn't matter which one you do first. If you're doing 3 of them, it'll still work. So the associative property of matrix multiplication. So that just says if you have a matrix A and then you're doing B times C first, that's the same as doing A times B and then multiplying it times C. You'll get the same answer. And then the distributed property actually goes kind of hand in hand with that, but it works as well. Of matrices. So if you have a matrix A on the outside and you're adding matrix B plus matrix C, that's the same thing as multiplying A times B and then adding A times C. The A does need to be in front from that because that matters with matrices. Okay. Now, just like there was a zero matrix, there's also an identity matrix. Okay, let's split this off and ends those properties. Okay, so the identity matrices. The 2 by 2 identity matrix is represented with I sub 2. And I sub 2 is the matrix 1, 0, 0, 1. Like a reduced row echelon. Like that, the left half. And then for 3, we are definitely not going any higher than a 3 by 3. Same deal, it's just a 3 by 3. So 1's down the diagonal and 0's everywhere else. Okay, so those are your identity matrices. Your identity matrices have identity properties. So if you multiply the identity matrix of whatever dimensions times the matrix A, you'll get the matrix A back. And this actually works the other way as well. If you multiply the matrix A times the identity matrix, you'll get your A back. Okay, and then an inverse matrix, this also goes with identity matrices. If you multiply a matrix times its inverse, a matrix can have inverses. If you multiply it by its inverse, you'll get the identity matrix. That will be the answer of whatever dimensions these two are. Okay, if you multiply the inverse times its matrix, same deal. You get the identity matrix for whatever dimensions they happen to be. All right, to find an inverse, which you can do this on your calculator also, but I'm going to show you how to do it by hand because that's good to know too. First of all, you're going to form a matrix with your matrix on the left, whatever you're given, and you put the identity matrix that goes with it on the right. You augment it. Then you're going to put that in reduced row echelon form. And you kind of let this just do its thing. And then once it's in reduced row echelon form, the new right side will be your inverse. Okay, so we're going to do that now. Number 35, we're going to find the inverse. I am not going to do this with a 3x3 by hand. That would be horrible, actually. This one, I'll show you the buttons for those of you who have a graphing calculator. But let's do it by hand first. So number 35. Oh, and like half the paper hanging off over there. Okay, so we're going to find the inverse. All right, so the first thing I would do is augment it with the identity matrix. So we've got 2, 1, 1, 1 with 1, 0, 0, 1. Okay. First thing I would do is switch the rows because you want 1 in the upper left hand corner. So I'm going to switch them. So 1, 1, and this tags along. So 1, 1, 0, and 1. And then the top becomes 2, 1, 1, and 0. Alright, now we want this to be a 0 would be our next goal. So we have the 1, now we want the 0. So our new row 2 will be negative 2 times row 1 we're going to add it to row 2. So we have negative 2 plus 2 will be 0. Oh, hang on. Let me write the first row down. Okay, so negative 2 plus 2 is 0. Negative 2 here, negative 2 times 1 is negative 2. Plus 1 would be negative 1. Then you have negative 2 times 1 would be negative 2, plus 0 is negative 2. Hang on, I'm losing myself. Sorry. Negative 2 times 0 is 0. Plus 1 would be 1. There we go. Negative 2 times 1 is negative 2. Plus 0 would be negative 2. Alright, I need this to be a positive 1 instead of a negative 1. So I'm just going to multiply. So our new row 2 will just be negative 1 times our old row 2. So the first row will stay the same. Our second row will just have all the opposite signs. We are almost there because we've got the 1, 0, and the 1. We just need that top to be 0. So our new row 1 then will be negative 1 times row 2 and add it to row 1. So negative 1 times 0 is 0, plus 1 it stays 1, which we needed that to happen. Negative 1 times 1 is negative 1, plus 1 is 0. Negative 1 times negative 1 is 1, plus 0 is 1. Negative 1 times 2 is negative 2, plus 1 is negative 1. This row will stay the same. And we are actually done. So the inverse of our original is 1, negative 1, negative 1, and 2. Okay, I want to show you how to do it on the calculator real quick, but I gotta get the calculator. Okay, so if I were to do this on the calculator, you know what, I have all those matrices we worked on before in here. So, you know what, I'm going to clear my memory. Second memory, 7, 1, 2. Just the easiest way to do it. And then they should be gone. Yep. Alright, so I'm going to edit letter A. It is a 2 by 2 matrix. Let's look at 2, 1, 1, 1. That's easy to remember. Okay. So back to my home screen. Bring up that matrix. Oops. And I want the inverse of it, which is that negative 1. It actually shares a key with it. And then there's my answer. Heck of a lot quicker than going through it by hand. So it's pretty easy to do the matrix in a calculator. Or sorry, to do the inverse in a calculator. I just want to show you something real quick. I'm not going to go through the steps of it. I just want to kind of show you that it does happen, that not everything will have a matrix. So let's say you have this matrix, negative 3, 1/2, 6, and negative 1. Oops. Okay, let me, second matrix. I'm just going to use that one. I'll just edit it. Dang it. Second matrix. Edit that one. It's a 2 by 2. Okay, we have -3. I'm just going to use 0.5, 6, and -1. Okay. And if I go to find the inverse of that one, so I go to second matrix, put that one in, oops, and then put -1. It tells you, oh, this one actually tells you it's a single matrix. They won't all do that, but there's no inverse. It's a singular matrix. So that whole process wouldn't have worked. You could have never figured it out. So I just wanted to let you know that that does sometimes happen. That does kind of stink about these, that you can't always get an answer, but now you know. That is the end of 11.4. I hope you're okay with it, and I hope you're staying safe, and I will talk to you again soon.